Hello, everyone. Welcome to our talk from Zero to GitOps and Spinnaker. My name is Fernando, and I'm a staff engineer here at Armory, part of a team working on the Spinnaker operator.
And I'm Akshay Dayal. I'm also from Armory. I'm a product manager, also working on the operator.
So today we're going to walk through a very high-level overview of Spinnaker and a couple of the different ways that you can use to manage Spinnaker's lifecycle. We're then going to go into a live demo where we'll show you the operator in action and how to build a simple GitOps workflow to manage your Spinnaker installation in your own environment. And then we'll wrap things up at the end and talk about what's next for operator and what the future holds for not only us as the team working on it, but from a community perspective and how you can get involved. So let's start off with what is Spinnaker. So if you're coming to this talk, you are no doubt familiar with what Spinnaker is and you're really interested in managing Spinnaker's lifecycle, but we'll go over a brief overview. It's an open source tool that enables multi-cloud continuous delivery and deployment, giving you single pane of glass visibility. So if you're deploying tools, and services to Kubernetes, to AWS, to Azure, Spinnaker is really the tool that's going to give you that one-stop shop visibility. And it's also composed of several microservices. So when we look at the 9,000-foot view of what Spinnaker is, it's about 10 different microservices that interact with a bunch of different cloud tools, CI systems, databases, and metrics providers. So if you are a developer on a small team, or if you are on a DevOps team that's managing a number of other development teams that are deploying to your environment, you're probably going to want a tool to manage Spinnaker for you. You're not going to want to manage all of these individual services yourself. So two of the tools that we recommend to our customers and that we use ourselves when we're developing against Spinnaker is Halyard and the Spinnaker operator, which we're going to be focusing on today. So let's talk about how you manage Spinnaker's lifecycle using a number of different tools that are currently available in the community today. The first one is Halyard. It's the tried and true tool. It's the one that's been around the longest, the most mature. This tool uses kubectl under the hood to execute changes for your Spinnaker installation. Your Halyard and Spinnaker config live on the same machine that you're running these commands from. It does introduce another command line tool into your workflow. So if you're feeling fatigued from using 15 different tools, this is going to be another tool in your tool belt. And Halyard, while it does provide validations, they do run locally rather than in the cluster. So what I mean by that is if you configure access to an S3 bucket, for example, and you run Halyard to apply your configuration, those validations will run, but they're going to run on your development machine. So unless you have assumed the correct role in your AWS account, you're going to be getting an incomplete picture about whether your Spinnaker installation will work when it's running in your target environment or not. So just to give you an overview of how this works, if you as the user are working on your Halyard machine, you've got your Spinnaker configuration files and you've got your Halyard tool ready to go. It's going to use kubectl to talk to the Kubernetes API server and stand up Spinnaker in that environment. The next tool that you can use to manage your Spinnaker installation are a set of Helm charts that are maintained by the open source community. So for those of you who are not familiar with Helm, Helm gives you a way to package and template up a number of different Kubernetes resources. So it's essentially a config layer that now sits on top of Halyard. Your validations are going to run deployed inside of the cluster. So talking about that Halyard mode where Halyard was running inside of the cluster as a pod, the Helm chart is going to do that by default. But now you've split your configuration between two different tools. So you might be configuring certain things in Halyard, you might be exposing different config options in Helm, and there may be drift between what's exposed in Halyard and what's exposed in your Helm chart. So what that looks in a diagram form is you've got your Helm chart over here with its own set of configuration options. You've got Halyard running inside the Kubernetes cluster with its config. And then whenever you apply that Helm chart, you're going to be executing those Halyard commands and interacting with the cluster. And finally, the third tool that we're going to talk about today is the Spinnaker operator. So this is an open source tool that is provided by Armory. And for those of you that are not familiar with the operator pattern, a very simple definition that you can use to think about operators is that they are essentially an encapsulation of human knowledge operating within a Kubernetes cluster. So what this allows us to do is define a custom resource definition, or a CRD, that encapsulates the desired state for a Spinnaker cluster. And then when you apply that custom resource definition to your cluster, the operator will know that this is the desired state for your Spinnaker cluster and will go take actions on your behalf. Now, the way it's currently architected is it uses Halyard under the hood to execute commands on your behalf. But we'll talk a little bit later in our What's Next section about the future of Halyard and operator. You can use our favorite configuration language, YAML, to configure everything in your Spinnaker cluster. And you can combine your Spinnaker and Halyard configs and any other Kubernetes-specific modifications you want to make in the same config format. It also automates common use cases for you. The one that we're highlighting today is deriving the URL for your deck and gate instances if you have defined an ingress object. This is something that it will configure automatically for you and make sure that the cluster is always in sync. But it also automates a number of other common use cases. And finally, one feature that we expose in the Spinnaker operator, rather, is using Kubernetes secrets. So if you are an existing Halyard user and you are putting secrets in AWS or you're putting secrets in Vault, you might be familiar with that halconfig syntax for referencing secrets. We've added Kubernetes secrets in addition to those existing sources in the operator itself. So this is an additional feature that you can get by leveraging the operator. So just to show what's happening at a high level here, you have your Spinnaker service manifest. So now we've kind of condensed all the different sources of configuration into one file. And then you as the user apply that, or as we'll show you in our demo, you can create a pipeline to apply that manifest on your behalf. The Kubernetes API server says, all right, this is our custom resource definition. It's going to notify the operator that there is something that needs to be done for your Spinnaker cluster. And then the operator will execute all of the actions that it needs to take in order to make the changes that you have made to your Spinnaker cluster a reality. And so all of this is happening inside of the Kubernetes cluster. So we've talked about 3 different ways that you can manage the lifecycle of Spinnaker. And you might be thinking to yourself, well, which one do I pick? And really, that's a question for your team and the skill set that your team has and the kind of risk that you're willing to take on as a team supporting Spinnaker for yourselves or on behalf of a number of other development teams. So we put together a little brief high-level chart for you to kind of help you decide. So if you're an existing Spinnaker user, you're very familiar with Spinnaker internals, you're very comfortable with Halyard, and you like the imperative approach to configuring Spinnaker, then Halyard is the tool for you. If you want to template values in your Hal config, but you don't really want to customize it too much, and you want a more declarative approach to configuration management, then maybe the Helm chart is the tool for you. And finally, if you want to templatize your configs, you want a more declarative approach, you want to use other tools in your existing Kubernetes toolchain. We're going to show you how to use Kustomize today. And you want common use cases automated and monitored on your behalf, then the operator is a good fit for your team. So now we're going to go into a live demo. Akshay is going to show you how to install the operator and how to create a Spinnaker cluster and kind of manage that with a GitOps workflow.
So what we're going to demo today is setting up Spinnaker from a customized repository. And the goal would be to create a pipeline in Spinnaker itself that uses a Git trigger to listen for updates to the customized repository. And whenever you make an update, let's say you want to add a new plugin or you want to change the version of Spinnaker, you make it in GitHub and the pipeline will get triggered and it will update Spinnaker itself. So this will demonstrate how to use the GitOps workflow for managing your Spinnaker installation. And we'll be showing a few things. First is we'll go over the initial setup. Then we'll create the pipeline with the trigger so that it picks up changes to GitHub and deploys them. And then we'll also show a couple of examples of making changes to Git. One is we'll update the version of Spinnaker, and then we'll also install a plugin by configuring it in GitHub and see it show up in Spinnaker. So the repository we'll be using as a reference is under Armory's spinnaker-kustomize-patches. In this repository, there is the entire configuration of Spinnaker is set up through Kustomize, so you can see the recipes available. And it's easy to basically add plugins here or change the configuration here. If you want to add support for S3 instead of menu or swap out something else, you can just update the customization over here and apply it to your Spinnaker. So I've already forked the repo for the demo today, and I've cloned it over here. And you can see the contents. The first thing we'll be doing is we'll be making this customization file a regular file instead of a symlink, because unfortunately, the symlink doesn't quite work with the demo. So the first thing we'll do is do that. Okay. And let's go ahead and edit the file now. And like I mentioned before, you can define various resources or make certain changes to your Spinnaker setup from over here. The first thing we'll be doing is we'll be changing the persistent storage for Spinnaker from Minio to S3. So we'll go ahead and do that, and we no longer need the Minio resource. And then we can go ahead and look at the persistence patch S3 file and make some changes. So we can configure both the bucket as well as the folder in the bucket that's going to be used for Spinnaker. For the demo, I will be using this bucket over here. And usually you can just leave the root folder as front50, but I've been using this bucket for prepping, so I'm just going to call it front52 for the folder. We'll go ahead and save that. The other thing we'll change is the version of Spinnaker that we'll be using. So for that, I'll actually update the Spinnaker service file. And at the very top, you can see the version. And you can change this to, let's say, 1.21.4. That's the version we'll start with. And the other thing we'll change is the account permissions for Spinnaker, so that when it does an apply based on the Git trigger, it has the permissions to go ahead and update the deployment. So that'll be in accounts Kubernetes and Spin SA. This is the service account basically for Spinnaker. So I can just go ahead and actually remove the file and just put in new information over here. And this will be different depending on your use cases. If you want to set things up slightly differently, or you don't want to use the service account, your configuration will be slightly different. But essentially what the configuration in here should allow is saying, hey, when Spinnaker is trying to deploy to the namespace where Spinnaker is deployed, in this case, it's going to be Spinnaker, it has all the permissions to make the updates to do an actual deploy manifest stage execution. So we'll go ahead and save that. The other thing I want to change is I want to add the GitHub account that we're going to be using for sending the webhook calls to Spinnaker whenever we make a change to the configuration, as well as just setting up all the Git trigger mechanism to be working. So I'm going to go ahead and update the customization file again for this. And I will add a section at the bottom that says that I want to basically be using GitHub and also use Git repo for this. Another thing I'd want to do now is that now that we've added that to the customization file is add a token for allowing Spinnaker to be able to communicate back to GitHub in order to basically pull files down. And the file that we're going to update for that is under secrets. And what you want to do is you want to copy the secrets example into its own file like secrets-env. And over here, there will be a GitHub token section here, and you will enter the GitHub token here. You want to make sure that that token has permissions, full repo permissions when you set that token up. And also, if you're using some sort of authentication, it has SSO access enabled, so it's able to do a clone or fetch all the files that it needs to from the repository. Okay, now with that done, we'll go ahead and do our first initial deploy in the cluster. You can see over here, I have my Kubernetes cluster, and initially it does not have a Spinnaker namespace or a Spinnaker operator namespace. And the way we'll do the deploy is we'll basically run this command at the root level of the repository from which we've had our customization files in. So we'll just go ahead and run this. And it's going to take some time. What it's going to do, it's going to create a namespace for Spinnaker. It'll create a namespace for Spinnaker operator. And then it'll go ahead and deploy the services in the Spinnaker namespace. And this, once again, is going to be 1.21.4 to start with. OK, and when it's completed, we can check the namespaces again. And we'll see that there's a namespace for Spinnaker and Spinnaker operator. We can go ahead and actually see what's inside the namespace Spinnaker. And you can see it is now bringing up the microservices that are needed for running Spinnaker. And we will wait till this is up and running. We can run a watch on it, but I'm just going to wait a little bit. So now the services are up and running. What I want to do next is access Spinnaker and make sure it's working correctly. Now, this Kubernetes cluster is deployed in Amazon, so it's an EKS cluster. So something you can do is set up an ingress or a load balancer to be able to access the Spinnaker installation. But what I'm going to show you today is another way to do that without having to set up a load balancer. And that is to basically port forward the deck and gate services so that they're available locally as well. And then what you can do is you can set up an Ngrok. And what Ngrok is basically allows you to do is set up a secure tunnel from a public address that routes to your local host. So now if I go to this address over here in the browser, you can see it actually routes to the Spinnaker that's deployed in the EKS cluster. And we'll give this a moment to just start up. So now it's up and running. You can see there's certain applications already available. What we'll be doing is we'll create a pipeline under the Spinnaker applications to go ahead and use the configuration available in this Git repository to make changes to Spinnaker. So coming back to our demo notes, what we've done is we've installed Spinnaker from the customized Git settings. We've added a GitHub account, and we've done all we need to actually enable the trigger on Spinnaker side. So the one thing we need to do still is set up a webhook on this repository. So when we make a change, it actually sends a notification to Spinnaker so that it can actually trigger a pipeline if needed. So we go to settings for this, webhooks, and over here, you can see I've already set this up for a demo previously, but what we want to do is we want to use the new Ngrok address that we have, and we'll update the payload URL to be the Ngrok address over here. We'll keep the content type application JSON. I do recommend that you use secrets for when you're configuring your triggers and webhooks. You can see for this, I just use Summit 2020 GitOps. That'll matter when we set up the trigger on Spinnaker side, so just keep that in mind. We'll remember that, Summit 2020 GitOps. And we'll go ahead and update this webhook. So now we're done with that. We are good to go to now create our Spinnaker pipeline that's going to listen for the changes to GitHub and trigger an update to Spinnaker. So we head over to Spinnaker over here. We can configure a new pipeline. We'll call it update Spinnaker. And for the configuration, we will add a trigger, and we will select Git for this. Repo type will be GitHub. Organization for this demo is army-io. The project name is this, so we'll copy that to make sure that we don't have a typo. And it'll be from the master branch. And again, we want to make sure we're using the same secret. And I will just double check and make sure. Yeah, you can just copy paste it as well if you want. Okay, so we go ahead and define this artifact, this trigger, save it. And then we'll add a stage. The first stage will be a bake. And the renderer engine will be customized because that's what we're using. We can say that it's going to produce a new new artifact from the GitHub repo. For the URL, we will just use the HTTP URL here. And master branch is fine. And we will provide the customization file, which is this top level file over here. I forgot to mention, we probably want to go ahead and push our local changes here out. So now that's there. We come back to Spinnaker over here, and this will be the customization file. And we can add another stage that's actually going to do the deploy now. And it'll be deployed to the Spinnaker namespace. And instead of text, we will just choose artifact, and we will choose the artifact produced by the previous stage. And that's it. This should be our pipeline. Okay, so now let's go ahead, and you can see that trigger is enabled for this. Let's go ahead and test it. So the first change we'll be making is just updating the version of Spinnaker. And you'll see we'll be upgrading to 1.22. And you'll see that there is a very different UI. So it's a very clear difference when you update it. So you go to Spinnaker service, you go over here, you make a change to 1.22.1. Push that change up. And over here, we should see our pipeline getting triggered. And once again, it'll do the bake, and then it'll deploy. And if we go back to our terminal, you'll see it's actually now updating Spinnaker. And this will take a few minutes. So now you can see the pods have been updated, and we should have a new version of Spinnaker running. The one thing I will mention is you probably want to stop and restart your port forwardings, especially the deck one at least, and we'll do that again. For Ngrok, I think Ngrok should be fine. You don't need to restart that. So now if we go Spinnaker over here and we reload the page, you'll see that the UI now looks different. In 1.22, there was an update to deck where things shifted around a little bit. It looks a lot slicker. So we can actually see the update did actually take effect. So now we've created the pipeline to update Spinnaker. We updated a git config, which is just a version to demonstrate the GitOps workflow. We'll do one more quick demo, which is to basically make a plugin available in Spinnaker. And the plugin is going to be a wait stage plugin. So if I want to add a new stage over here, if I look at wait, you can see there's only like one wait stage. So let's go ahead and add a plugin that enables the addition of an additional wait stage called random wait. And the way we'll do that is we come back to our repository over here. And if you actually look under the plugins directory, you can see that by just for demonstration purposes, we do actually show how to configure a plugin over here. And you can actually view this file and see what it takes to configure that plugin. And what we want to do is just add that plugin to our customization file. So we'll go at the bottom over here and just go ahead and add it like this. And we will go ahead and push this back upstream. And once this is done, you will see that Spinnaker will pick up the change and it'll trigger a deploy again. So it's doing the bake. And then it's going to be doing the deploy. And you'll see that the pods are getting updated. And we'll give this a few minutes. So you can see now that the pods have been deployed to. Once again, you want to restart your port forwards. And we'll come over here, reload this page. OK, so now let's try to add a new pipeline. And we'll call it like test plugin. And if we try to add a stage now, and if we search for wait, you will see that there's a random wait stage now also available thanks to the plugin. So to recap, we showed how you can use a customized setup, configuration setup to manage your Spinnaker configuration a lot more easily. And we did a deploy for that. We had set up a GitHub account and to enable GitHub Git triggers. We created a pipeline in Spinnaker so that Spinnaker could update itself based on changes made to the customized repository. We did a quick update of the Spinnaker version, showed that Spinnaker picked that up and updated itself. And then we installed a plugin and saw that Spinnaker was able to pick that as well up. So Spinnaker configuration management using a GitOps workflow.
Thank you, Akshay. That was a great demo. It was great to see how quickly you could get Spinnaker up and running with the operator and how you can manage those changes effectively to your cluster. I would like to spend the last few minutes here talking about what's next for the operator. So first on the list, if you've been following along with open source development in the Spinnaker community, you have no doubt heard of the Cleat configuration tool. It is a next generation way to manage configuration for Spinnaker and essentially is solving for a portion of the problem space that Halyard solves for you today. So Halyard currently manages configuration and generates configuration for each Spinnaker service, and then is responsible for creating the deployment manifests that you are going to apply to the cluster. Cleat is only handling that first half, that configuration management half. So what we'd like to do is migrate operator to use Cleat, since that is the tool that the community will be moving forward with in the future. And that understandably leaves you wondering, what about Halyard? So Halyard will eventually become a deprecated part of the tool chain. So you'll eventually need to migrate to something else. So you either use Cleat directly and then you define your own deployment yourself, or you continue to use operator and we will help you through that transition of moving your Hel config from the current Halyard method to the more Cleat style configuration. And operator will continue to manage deployments as it was before. So that means eventually that Halyard will remove its dependence, or sorry, the operator will remove its dependence on Halyard in future releases. We also understand that because we have this two container approach right now, error messages are a little bit hard to track between the two tools. So as a consequence of moving away from Halyard, we're going to be streamlining error messages. So it'll be easier to determine what's gone wrong and what exactly has failed in the validations that you have in operator. Finally, once we've done this migration to Cleat, we're going to donate this to the community. We really want this to be the tool that the community is galvanized around for Spinnaker development. If you were attending some of our workshops earlier in Spinnaker Summit, you will have seen the operator in action already. And we really want this to be the tool that folks use to get started and to develop against Spinnaker and to just kind of simplify the management of the entire Spinnaker ecosystem. And then finally, as we continue to invest in this product, we want to continue automating common use cases and making sure that it is easy to enable and disable features in the future. So thank you again for attending our talk, and we hope to see you in the community.